Alright, ready to rumble. Hello everyone, to day 14. 14? Didn't we do that like 2 days ago? Today actually we'll be covering day 14 once again, this time in Rust. Not sure if you guys remember about day 12 when we were dealing with pathfinding really. I found an amazing article by Faster Than Lime, whose name is actually Amos. He did his solution not only like brilliantly, but also in Rust. Rust. You hear that name pretty much all the time, especially since Stack Overflow's survey shows us that Rust is one of the most loved languages of all time lately, right? And it's like, I'm not sure, 5th year in a row, 7th or something like that. It's crazy. It's not really only the fact that it's so blazingly fast. You know me guys, I do love different languages. I do like to discover why different languages took so many different paths. And I really like to explore that and understand why and what for. So I've started to read about Rust. And believe it or not, Rust is actually very similar to F#. You can pretty much write functional code if you wish to. And most importantly, like, there's so many small things that are just so similar. Like, let's start with the fact that variables you define are actually immutable by default. They can be mutable if you wish to, and this is exactly the same in F#, right? The most basic types in the code, apart from integers and so on, are actually structs and enums, just like records and discriminated unions in F#. And the fact is actually enums can have a type underneath, so it's really a discriminated union by my standards. So let me take you through a brief comparison between solving day 14 in Rust and solving day 14 in F#. They're actually quite similar. By the way, huge disclaimer, I just started learning Rust. I'm writing it for about a week or so bear that in mind. There might be actual real-life bugs in here and things that are unconventional, to say the least. The tests are in the same file as the solution, right? I'm not sure how to separate them, so I can include this configuration of the testing. And now I just realized how I can do that. And we have to deal one more thing with double super, right? Okay, cool. Will that work? I'm very curious now. Yes, it does. Alright, this is perfect. So now that we separated unit tests, let's check out the solution. Let's start with the types. Let's focus on the Rust side for a moment. Okay, so first of all, we do have the point, we do have the line, super uncomplicated. Then we have the simple enum, so an enum that we find in C# rather than F#, because it doesn't have any particular types in them. But you can specify in here very specific type underneath, and this is super cool. This is why I'm excited about Rust actually. Okay, cool, let's go on. And now the important one is obviously the sand unit, which looks just exactly the same, right? We've got the position and we've got the state, and that's it. What else do we have in here? We are reading map in 2 steps. So first we read the points of the map, and this is exactly the same as map row or row map, yeah. Even the naming is similar, obviously. And then we are transforming that into a map. The curious thing in here is Rust also have a array and a vector, so something like a list. And I thought that since we made such a big deal about using an array in F#, my initial idea was to use an array also in Rust. However, it turns out that you cannot use an array in Rust when you don't know the size of it. So our map is actually a vector of vectors. Yeah, this is when we created a proper map. Count send units that settle actually accepts a function and it creates a Boolean value, right? So actually very similar once again to F#, where we even use the arrow for the type of the function. Thanks to that, we can actually specify the function here, and we can push it as a parameter, which is something that I really enjoy because, well, I do like functional programming. Big surprise, right? Now, here is a very important difference between Rust and F#, because in part number 2, not only did we include the floor in our map, but we also had one difference where the while condition was changed to this. So the while condition is a function that actually accepts the send unit, but it compares it to send starting unit, which is actually outside of the scope of the function itself. Which means, in short, that the function is really a closure, right? Or it utilizes a closure. Once again, the function is impure due to that. And this is perfectly fine. However, at the very first look at it, you don't see that. You don't see that it is actually a closure. I would really prefer to have I'm not sure, even a star in here or something, that shows us right away this is a closure rather than just a function. And this is exactly what we have in Rust, so I'm kinda excited. So as you can see, it actually uses a different specifier, because most importantly, it doesn't accept the parameters in this regular function way, as in parentheses. It actually uses those pipes to emphasize that it's not really a function, it's a closure. So now we have two functions. One of them accepts a closure, and the second one accepts a function. In Rust, you actually cannot use them interchangeably. Whenever a parameter is a function, you cannot use a closure there. But the other way around, that's completely fine. So whenever a parameter is a closure, you can actually use a function in here. And this is exactly what I did, right? Here we are using count send units that settle. So this is the same function, but here we are supplying a function, and here we are supplying a closure. And to keep it short and simple, well, Rust's syntax is not really super easy to pick up, at least I think so. I think F# reads just better. However, there are so many decisions that I really respect in Rust, and it's actually very, very interesting for me. Is there anything else really interesting? Yes, there is. Okay, matching, our favorite, definitely one of the favorites from F#, right? So this thing and this thing is the exact same thing. And I mean that like really honestly, because matching in Rust is really as powerful and as great as in F#. What I'm missing in here is in F#, you can quite easily do this when A is different than B, right? But I don't know, this may be possible obviously, but I don't know how to do this. I have no idea how to do that, and I'm kinda curious. So if you know, feel free to leave a comment down below. I would really appreciate that, actually. Once again, I'm a very newbie here in Rust, so I do appreciate all of the comments. There's a lot of discussions in terms of ownership and borrowing of memory, really. This is a very complicated topic, although it's not so hard to grasp. It's rather, it has a lot of intricacies in it, but it's really freaking cool once you get the hang of it. As you can see, you can write quite similar code. I do miss my piping operator. I really do miss that. It's once again so much nicer to look at this code rather than what's in here. But the idea is pretty much the same as in LINQ in C#. So you can chain those operations. What I'm trying to learn really is when you have to actually evaluate that, because all of this is completely lazy evaluation. To throw something into a list or something similar, there's actually a collect function in here, which does exactly that. Collect you can read as to list. So we've taken a look at writing LINQ in C#, or rather, yeah, just writing code on iterators in Rust. This is very good. I'm very used to it. I'm very happy it's here, and it's something I can read. Maybe not super easily, but I understand where that is coming from. So I'll get used to it. I'm sure I will. At the very end, because let's end this episode, I do have one more fun thing to look at, and here we go. So I created a very naive benchmark. So we have on the left Rust, on the right F#, and if we run both, let me find day 14, and look at this. Actually, 2,845 milliseconds and 4,800, which would suggest that Rust is actually slower. However, it's not that simple, actually. We can specify in here configuration release, right? And if you run that, it's a bit faster, it's 1,000 milliseconds, right? However, if we go cargo run release, it's 153 milliseconds. Like, it's kinda crazy. You can probably go 100 in here and 10 in here, and that would be the same, right? I mean, seriously, this is almost 10 times faster. Like, this is crazy town. I've never seen something like that. And this is kind of making me very happy. Or rather, it's just fun. I love this. I really freaking love this. Thank you very much, guys. I'm very happy you've been here. I'm very happy I had the pleasure to write some Rust, and I very much enjoyed it. I think I'm gonna do more. There's gonna be more where that's coming from. Thank you very much, and as always, we can do better as a pack. Bye, everyone. But we can parse not only the line of the input, but also the actual input, like the whole thing. And this is what this test does. This is what this test does. Yes, that was a mouthful, actually. Alright, so all in all, what we actually use... Oh, and I didn't rename that. Let's rename that, because that's not nice. Rename, yes, I don't want it to be test2, I want it to be a map. Is that good? That's good, cool. Because if we use cargo run, actually no, 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 no. Let's start here. Obviously, okay. So now we have separated tests.